Hi, today we're going to do number 704, binary search in JavaScript. So we're giving an array of numbers and they're sorted, and we want to return which index of the array is the target in. So for example, the target here is 9, so we count 0, 1, 2, 3, 4. 9 is in the fourth index, so we return 4. If the value isn't in it, so here the target is 2, there's no 2 in it, so we return -1. And then this algorithm has to be an O of log n, so that means we can't iterate through every possible value in the array to get the target, which is brute force. We have to use binary search. So there's a couple ways we can implement this, and the first one is the recursive way. And with this, we'll just have to call the function each time and cut it in half. And the time and space, time complexity of this will be O of log n, while the space complexity of this will be also, since we're creating a recursive function, each function gets added to the call stack every time you cut it in half, here and here and here and so forth. So it's also going to be O of log n. So how else can we do this? And that will be iteratively. And here we will use pointers, a left pointer and a right pointer, and use at the end, ends, both ends, calculate the midpoint, check if the midpoint is the target, otherwise if midpoint value is smaller than target, we change the left to midpoint plus 1. Otherwise, if midpoint is larger than target, we change the right midpoint, the right to midpoint -1. And we do this with a while loop. While left, and it could be equal to right. So while these two pointers while the left pointer is less than or equal to the right pointer. And then the same idea applies with the recursive one, but instead of we looping through, we're going to call the function again. And then the time complexity here will also be log of O. The time complexity will be O of log n, where the space complexity this time, since we're just using constant pointers, is going to be O of n. O of 1, I mean. Great. So since this iterative way has a better space complexity, we will solve it this way. But then afterwards, I will show you the recursive way. So we do a left pointer, and then the right pointer. Now we do the while loop. And here we calculate the mid. And we're going to floor it so we don't have to worry about decimals. So left plus right divided by 2 is how you get the middle. And now we check this value. If nums mid is equal to target, we return that mid. And now else if nums mid, we can do either way first. So less than target, our current mid is too small, so we have to push the mid over. So we do left equals mid plus 1. Now we just do else right, if it's too small, mid minus 1. And then if it doesn't hit this, we return negative 1. So we see here negative 1, 12, and then the mid will be 3, I believe. 3 is not it, so we move the left to here and here, and then you calculate the mid there. Great. So let's do it the recursive way. So here we don't need left and right function. We need to call another function to do it. So we can call binary search. And we pass in the left. Starts off with 0. And the right, nums dot length minus 1. Pass through nums and target. So here, let's define it. So it takes in left, right, nums, right, and then the target. And we do the same idea. So we checked I can't think of the case where the recursive ends, and that is if right is greater than left, we return negative 1. And then let's calculate the mid. Great, since we have the mid, we can compare the values. If that's equal to the target, return mid. Otherwise, if nums mid is smaller than target, we have to change. So our value is too small. We have to change the left value. So here we do mid plus 1. And then our right will be the same, nums the same, and target the same. Else, if it's smaller, we have to reduce the right side. So the left side will stay the same. The right side will be mid minus 1, nums, target. So this edge case needs to be left when it crosses. And then we have to return when we call it recursively. Oh, I forgot to pass target. Great, so that's how you do this problem. You have to do divide and conquer approach, where you can either do it iteratively, where you use pointers to see each one and then narrow it down, or you call the function again through a recursive call, and you manipulate the inputs to make that happen. Thank you.